Now that we know what the definition of a relation is, we can talk about a function. A function is defined by first starting with a relationship or a relation between two elements, x and y. So if we go back up here to our previous talk where we had a relation between your age and your survival rate, you can see that, again, we had the relation between the two elements up here. Now, further talking about the definition of a function, we have x as the input and y as the output. So if the domain is considered our x value and y is considered or the range is considered the y value, x is my input and y is the output. If I put in an age of 70, then my output is going to be 86%. We also say that for a function, for every x, there is exactly one y. So if I put in a value, an age of 90, then I can expect a survival rate of 24%. That is the definition of a function, and we'll look at that a little bit further in a second. And then finally, to define our function, our x values, which is the domain, are considered independent, like we've said, and the y values, which is the range, are considered dependent. Let's look at an example then that's going to help us to determine whether or not the relation I'm looking at is a function. So I don't know if it is or not, and while we're at it, we'll talk about domains, ranges, independent and dependent. So first, let's define which of these two categories here is the domain and which is the range. Now remember that the range is going to be dependent upon the domain. So I can see that the fat content in a hamburger, which is what I'm looking at, a series of hamburgers here and their fat contents, the fat grams is dependent upon the number of calories that are in the sandwich. So that tells me then that the calories would be domain and therefore independent, and the fat would be the range and therefore dependent, right? Because the fat depend on the calories. Okay, so now that we have clearly defined which is our domain and range, let's determine whether or not this is a function. When we think about a function, start with an input. If I go to the fast food place and I buy a Wendy's single hamburger that has 410 calories, I can expect there to be 19 grams of fat in it. If I go to Burger King and buy a Whopper which has 540 grams, I can expect there to be 24 grams of fat. Let's look at this one here. Burger King chicken sandwich has 750 calories with a fat content of 23 grams. And although McDonald's has the same fat content for their sandwich at 23 grams, if I go to McDonald's and I buy this McChicken, I can still expect there to be 23 grams of fat. Because there is exactly one y for each x, that defines this as a function. So this is a function. The best way I like to think about it is if I have an input, do I know what my output is going to be? And yes, in this case I did. Let's look down here at this example. This is an example showing the weight of a diamond or the weight of some diamonds and the corresponding price of the diamonds. Now, defining domains and ranges, I know that the price of my diamond depends upon the weight that it is given. So the carats over here would be the domain and the price is the range. Now, if the definition of a function says that for every x there is exactly one y, we can see that right here that just threw this out. This is not a function. Now, let me give you a scenario, though, for you to kind of understand that a little more clearly, because there's a bunch of lines that are crossing up here. How do I know that this wasn't a function? Again, it has to do with the fact that for each x, there is supposed to only be one y. Now, let's go back to the idea of I want to know what to expect. And let's say that I go to the diamond store and it's my anniversary, it's coming up, and I pick out the biggest, fattest diamond that there is, and I am all excited because I can see that this diamond's only on sale and it's only $3,000. So I go home and I sweet talk my husband, and he relents and he goes back to the jeweler and he picks out this same diamond, but the jeweler is going to sell it to him for $3,300. That's not what he was expecting, is it? He was expecting to get it for $3,000, but the jeweler was going to sell it to him for $3,300. So if I have an input and I'm not quite sure what the output is going to be, because I have multiple choices for an output, that tells me that I don't have a function. Let's look at this now in a little bit of a different light, and let's look at it and determine whether or not a relation is a function simply by a set of values. So here I have 4 ordered pairs given by the set brackets here, and I want to determine whether or not it is a function. Now, if the definition of a function says that for every x there is exactly one y, we can look in here at each of these x values and make sure that the y values that correspond with them are all different. And sure enough, they are, so this is a function. Now let's look at this set of ordered pairs. I have 5 ordered pairs over here. Again, my definition of a function is that for each x there is exactly one y, or in other words, if I'm given an x, do I know what the y is supposed to be? Hopefully you see in here that this -3 for the x on the first ordered pair and this -3 on the last ordered pair is what's going to throw this off, and it's not going to be a function. Because if I were to put in a -3 for x, I could get a 9 or I could get an 8. That by definition means that this is not a function.